This conference will now be recorded.
Yeah, great. Hope you all enjoyed the Diwali. And yeah, so today we are starting the Docker, okay, which is a very important concept actually. Once you understand the Docker, right, then only you will understand the Kubernetes. Okay, so which is the next part of the Docker. And Docker is the next part of the virtual machines. And the virtual machines we have already discussed within our foundation sessions, right? And when we are starting the Docker, right? So first we will start with why do we need a Docker? Okay, and then we will look for the what is Docker. We have already discussed these things in the introduction of DevOps, right? What is the containerization? Okay, so Docker is what the container engine, right? So we will discuss within that point what is Docker, and then we will see the Docker installation, and then we'll see the Docker lifecycle. There are a couple of points within the Docker. Okay, so I will cover Monday to Friday this week. Okay, I will finish Docker in 1 week, and I will finish the container in 2 to 3 days. Then we'll start the Ansible. Then we'll start the Jenkins. Okay, then NagOS and the rest of the things and the projects. Though, so I'm trying to finish this course by first week of December, so you guys can start looking the new opportunities in market or the internal as well. And the interview questions and all, right, I'm getting a couple of pings related to the interview questions. So don't worry guys, once we finish the Jenkins, right, it seems to be too early for me now. So once we finish the Jenkins, right, I will share the interview questions as well. And I have received a couple of CVs from you guys. I am closely working on those actually, and I have prepared a couple of points. I will schedule once we finish these sessions, all the sessions, right, during the projects, right. I do not have any work. I do not have any session for the projects, right. I just give an idea how to implement that. You guys will implement those projects. And within that time, I will schedule one-to-one calls, around 15-20 minutes calls, okay, to each one of you, and I will get those CVs updated. Okay, and then we will share and interview questions as I will already share, right? How to give the introduction, how to express the projects which are not comes under the DevOps. Okay, all the things I will give within those CV preparation stuff itself. Okay, so don't worry about it. So only intention is when you guys are pinging, so that's the reason I'm telling within this session. Okay, so why do we need a Docker? Let's imagine. Let me do one thing. Uh, I don't want this. I will open my favorite tool, which is Paint again. Okay, so let's assume you are the developer. Okay, you are the developer. This is bit theoretical session, but it is required to getting all the concept right. So you are the developer, and let's consider you are a PHP developer. Okay, you are creating a website within the PHP. I seen the name of Vidya there, so he is a PHP developer, so that's the reason I took the PHP here. And you are preparing a website within the PHP. Okay, so what you need when you are writing a code for a PHP? Okay, let's assume you should have OS, right, operating system, and on that you can use any tool. You can use Notepad++ for doing those PHP code and okay. So what you need for writing a code, right? So you need the operating system, you need operating system, you need some tool in which you can write the code, right? It can be the Notepad or something like that. The code you are writing with, you are writing for the PHP. Okay? Any tool, anything. Okay? So once this is available, then you are able to write the code. Okay? It is not possible, right? Within the mobile phone, it is not possible to write a code, or you are writing the code on the notebook. Then it is very hard to convert again, right? For that also, you need any one of the core, one of the tool and the operating system, right? So running those code, validating that code. So what you need the PHP software, right? You need PHP software, PHP software. Okay, you are not you haven't installed the PHP any software or Java or anything, and you are writing a code. Will it work? No, right? There is some mechanism should be present, which will help you to convert that code, which will help you to what I can say compile that code. Okay, that mechanism should be there, right? So that's why you need a PHP software, right? And then, for example, you have written the code and everything from blah 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 everything, right? And what you wanted to do is you have to you have to you are connecting from your application to, let me take this as application. Okay, so what your application is doing, your application is in it is a web-based application, web application within the PHP. Your application is connecting to the database as well. What you need, okay, what you need libraries, binaries, right, for those database. Okay, otherwise it will not connect. The libraries are missing, then it will not connect, right? And another example is, let's take an example. Your database is connecting any APIs. Okay, those libraries should be specified, right? Otherwise it will not connect. And for example, you are using any frameworks, Joomla, WordPress, anything for the PHP. Okay, those libraries should be maintained somewhere, right? So libraries are required. So you need libraries and binary files as well. Okay, libraries, libs, and binaries, bins. These are required. Then only the code which you have written within the PHP will work. Otherwise, it will not work. Okay, so once you done with your code, once you have written everything is in place, okay, in your machine, libraries are there, binaries are there, PHP software is there, and OS is already there, right? On that tools itself you have installed this stuff, and your application is ready. Okay, I'm sorry. So your application is ready. Okay, so once your application is ready, what we will do, you will give your application to the production guy or the operation guy to deploy on the production and check it, or a tester as well. Okay, so check on the production environment. Okay, so you will give it to the production guy. Okay, I will take an example as production guy. Production guy. So what he will do, he will check that application. He will deploy that application in his machine, and in the production machine, or in his machine, and he will give the feedback to the developer. Okay, let's assume in this use case, what are the things required? You need to write a code or a program, right, or a software, right? You need to build a software. What you need to run this application, what you need to test this application, or what you need to test this code, you need operating system, you need PHP software. Okay, as we have taken example of website in PHP, right? And you need a binaries and libraries. Okay, it should be present. Okay, so once you done with your code and program ready, okay, what you will do, you will give that code to the tester or the production guy. Okay, and you used your machine to run the code. Okay, you use your system to test your application. Okay, and it is running properly. Okay, so once it's done, you have given to the production guy or a tester. Now what production guy is doing, he's trying in his machine, but it's not working, and he's saying like it doesn't work on my system, it's a faulty kind of code. Please check. We'll definitely say, because he's not a developer, right? He just deploy that and he will try to run that. So, and developers say no, it's working fine with my machine. Okay, so, and it seems to be your hardware issue. the developer will show. It will go into a different way, right? It will go into the conflicts, right? So if you think here, it's not a problem of the developer, or it's not a problem of the tester guy or the production guy. It's a problem of the available libraries, available softwares. Okay, it should be that particular machine, for the production machine or the tester machine, should be compatible with the these stuffs, right? He should have that proper use. He should have he or she should have the PHP software installed. He or she should have the libraries and bins should be present. Okay, this is the actual problem. So for this, what was the solution earlier? Okay, I'm not going directly to the Docker. Okay, what was the solution earlier? Earlier solution was the virtual machine. What can developer do? He can build one virtual machine in which he can write the code, he can do all the things. Okay, and the same kind of virtual machine he will provide to the production guy or the testers. Okay, production guy or the testers. So what they will do within that, they will use the same virtual machine and they will just run those tests, or they will just deploy and test the application functionality and everything. So it will work, right? It is kind of a viable solution for the problem, right? It is a kind of a viable solution, but it's not kind of a permanent solution. But previous before 3 to 4 years, it was the permanent solution earlier, before the containerization. But in that situation also, there were few loopholes as well. Okay? So what are those? The virtual machines were very huge in the size, right? And for sharing those virtual machine from doing the portability for those virtual machine from the development to the tester guys to production, it is very time consuming. And second thing is, he has created one feature, he has implemented one feature, developer has implemented one feature, login page, and he's giving to the this production guy or tester for further things, right? And next day, after next week or after a few days or few months, new feature is coming into the picture, and that feature required different libraries, three more libraries. Okay? What developer have to do, he have to install in his machine, then he have to suggest the production guy install this stuff, okay, and run the package whatever we have provided to you. Okay, whatever software website we are giving to you. So what it is doing, when the feature xyz is required, three more libraries or three binaries, anything, right? It is, and which is not with the production guy, then he have to install or he have to get it from the production development guy. Okay, it seems to be inconsistent. If I'm writing the code, I'm providing the virtual machine, it should be support to the production guy, it should be support to the tester. It should not happen that it should not happen like in an inconsistent way, right? So that's why there these two issues, these the very huge in the in the size. Okay, very large, virtual machines are large within the size. Okay, and one second guys, I'm getting a call once. Okay, fine. So very large in a size and very complex to use. As I mentioned, right, if any new feature is coming in, new libraries should be present within that virtual machine, that those should be installed at developer end, those should be installed at production end. Okay, so it is kind of a complex situation, right? So this is the problem before the Docker came into the picture. This is what, this is the problem. Two things, whenever the interviewer asks you the question why Docker is present, your answer should be, previously virtual machine were the solution for these kind of situations, right? And those were the virtual machine were having the size, and the virtual machine size is very huge. This is not easier to do the port, okay, from one machine to another machine, right? And the virtual machines are very complex to use. Any new library is required, then it will go into the inconsistent state, right? So we need to install that and it will again try. So it is kind of inconsistent, right? So that is the reason Docker come into the picture, containerization come into the picture actually. Okay, so what we need as a solution, we need a solution as a wrapper. We need a solution as a wrapper. So in which we can include all the required operating system, all the libraries, all the binaries, okay, all the relevant softwares, etc. And it should be same for all the environments. In the virtual machine, I'm the developer, I'm using one virtual machine, and same virtual machine I have created and provided to the production. And but the virtual machines are different, right? If I'm installing something on the developer virtual machine, the same should I need to install within the production environment, right? So here, what I can do, I can just pull one virtual machine, one Docker image, the same Docker image, same container I will use for the rest of the environments. Okay. So how to do that? How to pull those image? How to create a container? How to uh, uh, stable your container? All these things we are looking into the practically. Just concentrate on the concept. Okay. So we needed an entity which can contain all the software dependencies as well as can be portable. Okay, it should be portable on other computers. It is like a plug and play package. Okay, it should be a plug and play package. Previously, in couple of years back, okay, you guys should have a VLC kind of software. It is the video player, something like that, right? So some of the videos, if and I'm having another player which is the Windows Media Player. So Windows Media Player, we are not supporting MP4 kind of files or VDO kind of files, dot video kind of file. But VLC player was supporting. Okay. But nowadays, what Windows has done, Windows has built the software, Windows Media Player software like that. Any kind of media can play within it, right? So here is the difference. The older Windows Media Player was the virtual machine. I'm just giving an example. And the current days Windows Media Player is the containerization, which supports everything, right? So now we need a wrapper which contains all the files. And that wrapper is what it is containing? It is containing everything. Okay, this stuff. I'm sorry. It is containing this stuff. Okay, this is nothing but the wrapper. And this wrapper is known as container. This wrapper is known as container. Okay. So now I will do one thing. I will compare this. We have seen this diagram in our introduction to DevOps, right? So I'm just recapping this. What virtual machine is having? Virtual machine is having host machines. Okay. Then it is having the infrastructure, which is nothing but a hardware. Then hypervisor for managing the resources. And then guest OS. Okay. Then again, guest OS are utilizing the resources using hypervisor. And on the guest OS, we are having the apps. Okay. Guest OS are nothing but the virtual machines and apps. And apps are again utilizing the resources, right? From the guest OS. And the same is utilizing from the host machine, right? And here within this image, we are having the kernel here. We are having the kernel here. Container engine is nothing but a Docker. There are a couple of types of container engine available in the market, but Docker is one of the most famous. Okay, and all 98% industries using Docker. We are having host machines, infrastructure, which is nothing but the hardware. Container engine, which is nothing but a Docker, okay, or any other container tool, container engine. Okay, Docker is the container engine, and it is having couple of containers. It is having a couple of containers, and each of the containers can have one or more applications. Okay? And those are having the binaries and libraries, but those are not having any operating system. Okay, those are not having any operating system. It means it is not having any irrelevant files to that particular container. That is the reason that container is in lightweight within the size in compared to the virtual machine. Okay. So now Docker. What is Docker? So Docker is I can say Docker is a computer program, okay, that performs. We can say, okay, definition is not here. Okay, I will write a definition here, no issues. But I will first cover this slide. A Docker is a computer program that performs operating system level virtualization. Operating system level virtualization. If you see the example here, this is the container image, okay, container architecture, we can say. Hardware, operating system, the container engine. Container engine is having the kernel, okay, and what it is doing, what container is doing, it is performing the virtualization of the at the operating system level. There are BIOS, there are other OS related stuff. It is getting virtualized, okay, based on the containers. It is getting virtualized, which is based on the containers. So you need not to worry about it, how this Docker is utilizing or archiving, oh sorry, not archiving, virtualizing the operating system. You need not to worry about it. It will be taken care by the container itself. It will be taken care by the container kernel itself. So it's not a part of the DevOps engineer duties. What is the DevOps engineer duties? Is the container is ready? It is started state or not? Okay, the container is how much utilization is happening for that particular container. Okay, and how can we take the different images on the containers? Okay, those things are required for the DevOps engineers, right? Then, as I mentioned, Docker is a computer program that performs operating system level virtualization, also known as the containerization. It is also known as the containerization. It is the computer program that performs the operating system level virtualization. Okay, it was the first released in 2013. Okay, sometimes if you get the ad, the job ads or something like that, right? Or if you see on the Naukri, or if you get email from the Monster or somewhere, right, on the job portals, they mention 10 plus years experience required. Docker itself not having the age of 10 plus years, right? So those, it means your total experience should be required at 10 plus, okay, if they are giving an ad like that. And you should aware about the Docker concept. They are not expecting much from you. You should aware about the Docker, how to create a container, how to pull the images, okay, how to start stop the containers, how to sleep the containers, okay. These concepts you should aware, how to deploy the application on the container, how to go into the container, okay. These concepts you should aware, right? They are expecting it. So as I mentioned, I will write, otherwise I will forget. Docker is a computer program. Docker is a computer program that performs operating system level virtualization. Okay, and it's also known as containerization. Spelling is a bit difficult for me, so I'm just copying it. Containerization. Okay, and it was first released in 2030. Okay, and developed by the Docker Incorporated. Okay, developed by Docker Incorporated. So this is the organization who has introduced the Docker containerization. Okay, so now let's go ahead with this one. What is Docker? As we discussed the definition at the moment, and also we have seen one of the image from here. Okay, container engine is nothing but the Docker. Okay. So now the same we will just run through the development. This is the one of the great document I got from one of the source, right? And here the development. Let's say you created an application and that's working fine in your machine, but production it doesn't work. This is the production guy. Developers experience it a lot, okay? And the same which I have explained for the PHP example. This is when the developer's famous words are spoken. The same, like it works on my machine, your application is not working. The particular production guy or the tester is saying to the developer. And then the reason could be due to the dependencies are not present, due to the libraries or the binaries are not present, due to the frameworks which are not present. Okay, operation OS level features are not present. Okay, anything can be the reason, right? That the developer machines has, but not there in the production environment, which is missing, definitely which is missing within the production environment. That is the reason it is not working, right? Then the Docker. So Docker will come into the picture in this kind of situation, this kind of the prevention for this kind of situations, right? We need a standardized way to package the application, which is its dependencies, and deploy it on the any environment. Okay, it will create a package and we can deploy on the any kind of environment. Docker is a tool designed to make it easier. Okay, Docker is a tool actually. You can say anything. I have written the definition here. Docker is the computer program that performs the OS level virtualization. It also knows the containerization. Okay, so here, sorry, Docker is a tool designed to make it easier to create, deploy, and run the application by using the containers. Okay, then how does Docker works? How does Docker works? The container itself is having its own meaning, right? Container, which is containing anything, which is containing everything, right? Docker packages an application and all its dependencies in a virtual container, okay, that can run on any Linux server, Ubuntu, CentOS, anywhere you can run it. Okay, and each container runs as an isolated process. Each container runs as an isolated process. You can have multiple containers on the container engine, as I mentioned here. You can have multiple containers on the container engine, right? And on that you can have multiple images like CentOS, like Java, anything you should have. You can have, right? And the kernel will come into the picture with along with the container engine, along with the container engine. Okay. So the user space and take up less space than the regular VMs due to their layered architecture, right? Which is not having any what I can say, the guest OS machines, right? Virtual machines. It is having just a kind of a required. It is kind of a package which is having the required binaries, required libraries, okay, required OS files. That's it. Then, and this is what we have already explained. So it will always work the same regardless of its environment. Once you create that package, once you create that container, you can use same container in all the environments. You can use all the containers within all the environments. So we will see this in the practical sessions as well, how we are creating the containers, okay, how we are deploying the application, everything we will see. So this is about what we discussed before this one, right? Now, before the containerization, we have seen, this is the example we have seen, virtualization was there, right? So what was the disadvantages of this? Virtual machines took too many resources to run, right? Too many resources to run. It requires the guest OS machine. Along with the guest OS machine, what it needs host machines, and using that and we can deploy the application on the virtual machine, and those applications are running on the virtual machine. It is utilizing the resources from virtual machine to the guest OS machine, right? Sorry, host OS machine. So it means it is taking lot of resources to run, right? VMware big in the size to be portable. As we have seen the example, this one, right? So if we are need to port this, port means we are just running those virtual machine from the development environment to the tester or the production environment, right? So it is bit complex. It is bit uh, big in the size, right? It will take some time, right? So that is the reason it I have mentioned here the things. Okay? Virtual machines are not developer friendly. These are not developer friendly because containerization is a developer friendly and it can be configured through the code itself, right? So that is the reason these are not a developer friendly. Okay, and come to the containerization. What containerization is? It is same, right? Containerization is the concept. And what are the containerization tools? Like Docker is there, Arcade is there, then Mesos is there, right? And we'll see within these tools. I will discuss further things. Okay. The containerization, the application containerization is OS level virtualization method. Okay, method to use to deploy and run the distributed application without launching enter VM of each app. We need not to launch the virtual machine. Let's take an example. You have deployed one application on the virtual machine, okay, and your virtual machine is down. It is in stop state. You have to start it, right? It will take some time to start and to run, and it will take some time to run. Here you can it will be very easier to start your container. It will take hardly 2 to 3 seconds to start because it is very small in size, 70 MBs, 90 MBs, like that. But for the virtual machines, it could be 1 GB, 2 GB, like that, right? Depends upon the OS we are using. So this is about the containerization advantages of container. Sorry, advantages of container are containers are not resource hungry. Okay, it is not taking so many resources in compared to the virtualization because it is having their own libraries, own required OS, own required softwares within it, right? So it is not required. It is not required the software from the your virtual machine where virtual machine should have that software installer like that, right? So it is not required. It is not taking a lot of resources from the virtual machines to the host machine, guest machine to the host machine. It is not taking so much space, so much memory, right? It is very lightweight. Okay, and it is portable. It is portable friendly actually. Why? Because they are very lightweight in compared to the virtualization. You can use same in all environment. Okay, same package within the all the environments. Okay, they are developer friendly and configured through the code. The same we are looking with the practical, how we are configuring, how we are starting, stopping via the command line. Okay, we will look into it. And here containerization tools, RKT, 1% of industries using this tool, RKT. Mesos, 1% of industries using Mesos. Remaining 98% industry is using the Docker itself. Okay, it means Docker is very boom, is in very boom, okay, which is very boom technology. And along with Docker, they are using Kubernetes for the scaling. We will see within the Kubernetes how Kubernetes works. Okay, it means Docker is in very famous tool actually. So now we have seen the definition of Docker as well. Docker is a computer program that performs the OS level virtualization. OS level virtualization is also known as a containerization because it's a containerization tool. It is a container engine actually. Okay, and Docker is used to run the software packages called as a container. I will write one more line. What I told, Docker is to run software packages called containers. Okay, all the software package will be called as containers and which is running via the Docker engine. Okay, what is Docker engine, what is the life cycle of Docker. Okay, we'll see within the Docker life cycle. Okay, So it is released in 2013, okay, developed by the Docker Incorporated. This is the bit theory about the containerization, difference between virtualization and the uh, Docker VMs and Dockers, okay, and the Docker we have seen. Any queries in this before I go ahead go ahead with the another concept?
No, Tanvir.
Okay, great. So now what I will do, will show you the third point, which is installation of Docker. Okay, so what I will do, I will create one instance here, Docker lab kind of instance. I create launch instance, Freedia Ubuntu 20. Okay, free tier 1. Next, I will use available one, add tag. I will make Docker lab. Sorry, name Docker lab. I will use. Next, and here in the security groups, I will use all traffic anywhere and review and launch. Okay, launch. We'll use existing one actually, which is Git server. Okay, acknowledge, launch it. It is launching. It has, okay, it is running. It is pending it. It's pending still. The name tag I have mentioned within the small, right? That's why it's not taken a name here. What I will do, I will give the what was that? Docker lab. Okay, so it's ready, right? So take this up, copy the local host. What happened? It is getting hang. Copy this. Go to Mobextem. I will create new session SSH remote host and Ubuntu private keys. Git server. Okay, it's connecting. Okay, it is authenticating and it has connected. Okay, first clear the screen. Sudo su for the root user. Okay, once you go to the once you create any new instance, what you usually do, you will update, get it update, apt update is updating the packages. Great. Let's clear the screen. Okay. And what I wanted to do, I want to install. Okay. And anyone using Mac OS, then I will provide different way. Okay, just ping me on the WhatsApp if anyone using Mac. So for this one, what I will do, I will use the command apt install docker apt install docker.io and -y for the confirmation. So what it is doing, it is installing Docker here. Installing Docker. It will take few seconds and it will get it installed. It's a one-time activity for any project. If you get a new project, right, it's a one-time activity. When you're building the environment within your organization, organization means, for example, you are using AWS or any Cloud Foundry, any cloud related to Azure. So it's a one-time activity. So and you during that time you need to install that. So I will just clear that. What I did, I have installed the Docker now. I want to check the version of the Docker, right? So what I will do, Docker ---- version. So it is showing the version of the Docker. Okay, current version of the Docker. There is one more command, Docker without -version. What is showing? Client and server. Why? Because Docker is having client server architecture. Docker is having client server architecture, and communication between the client and server, which is happening via the REST APIs. Any request which is coming from the client and which is getting processed by the server, it will be happen via the APIs, REST APIs. Okay, that we will discuss within the lifecycle itself. So don't worry. Just keep in your mind two kind of versions will be present for the Docker: host and client. This is important question for the interview. So they will ask, what are the types of versions within for the Docker? Client and the server. Why? Because Docker is having client server architecture. Communication between the client and server, which is happening via the REST APIs. Okay, REST API is nothing but your business logic. Okay, so that's why I have covered it today itself. But we will discuss the lifecycle and the Docker engine flow and the lifecycle. Then we will start rest of the practicals tomorrow. So any queries, any concerns, any questions, guys, within this before I stop the recording?
No.
Okay, fine. Okay, that's fine then, guys. I will stop the recording then. Okay, and we will connect by tomorrow again by same time. It is very interesting. Once you just listen these recordings, okay, what we have discussed today, and I will share the content as well, what we have shared in front of you. So you will get an idea about the Docker. So how Docker works, how Docker can get implement, that everything we will cover within the practicals. There are a lot of concepts in the Docker. Okay. So I'm stopping the record.